Good evening. Thank you so much for joining us. I am delighted to welcome you to the first edition of the second semester of this year's Crossroads of Ideas series. My name is Laura Heisler, and I am the Director of Programming for the Wisconsin Alumni Research Foundation, one of three organizations that call this building home, the other two being the Mortgage Institute for Research and the Wisconsin Institute for Discovery. And this series is a collaboration among the three of us to try to do justice to the space that we're in, the town center, which was always envisioned to be a true crossroads between the campus and the community, and really be a crossroads of ideas, hence the name of this series. Can I get a show of hands of those of you who have been to other Crossroads of Ideas talks? Great, welcome, thanks for coming back. For those of you who haven't come, what we try to do in this series is tackle subjects that affect all of us as members of a society. Sometimes those subjects relate to the natural sciences, sometimes they're topics in the social sciences. What they have in common is that they matter to all of us, and they're also the subject of research here at UW-Madison. And tonight's talk is no exception, and I will be turning things over to the CEO of the Mortgage Institute for Research to introduce tonight's speaker, who is a very fitting person to kick off this semester of this semester's Crossroads. I do, though, want to give you a couple of notes about how this session's gonna go, and then put in a plug for the rest of the semester and the other talks that you can expect to see. So for this one, we're going to have a lecture, and then we're going to end the last 10 or 15 minutes with some audience question and answer. We do record all of these. We'll be posting a video online in the next couple of days on the discovery.wis.edu website. Because we record it, if you want to ask a question during the Q&A, I'm going to ask you to raise your hand and wait for one of the mic runners to reach you so that we can capture the question, and also so that everyone in the room can hear you. So if you could just be patient and wait for the mic, they will make it to you. And then in terms of the rest of the sessions, we only have one each. We have one in March and one in May. We're skipping April. There are some holidays that are in the way in April. These sessions typically take place on a Tuesday night. This week is an exception because Tuesday this week was a really special day. So we decided to move it to Thursday. But coming up on March 14th, very appropriately for March Madness, we'll be hearing from Laura Albert McClay on bracketology, so you won't want to miss that. And then we'll be ending the semester with New York Times bestselling author and a person whose TED Talk has been viewed almost 1.5 million times, Alice Goffman, a professor of sociology here at UW-Madison. So if you signed up and got an email for tonight, you'll get emails about these. If you signed up at the door, we'll add you to our list, and you can certainly find information about these on the Discovery website, and we also have an ad in Isthmus the week before. With that, I'm going to turn things over to Brad Schwartz to introduce our speaker.
Thank you, Laura. It is my pleasure, my distinct pleasure, to introduce Joe Handelsman, tonight's speaker. Dr. Handelsman is the new director of the Wisconsin Institute of Discovery, which is one of the institutes in this wonderful building. This is a research institute that is just entering its sixth year, that is dedicated to facilitating interdisciplinary research spanning biotechnology, nanotechnology, and information technologies. Dr. Handelsman is also joining the Department of Plant Pathology here at the University of Wisconsin. Dr. Handelsman is quite well known both nationally and internationally for a wide variety of activities and accomplishments. Most recently, Dr. Handelsman concluded service as the Associate Director for Science and Technology at the White House Office of Science and Technology Policy under President Obama, where she advised the president on policies to address current and future challenges in science, engineering, and mathematics. Dr. Handelsman is a distinguished scientist who helped create the field of metagenomics, and whose current research focuses on the way bacteria communicate among themselves to create robust communities. In addition to her internationally recognized research, Dr. Handelsman is also an international authority on evidence-based education, for which she coined the term scientific teaching. To advance science education in the United States, Dr. Handelsman has co-founded 3 different programs focused on teaching principles and the practices of evidence-based education. These are the Wisconsin Program for Scientific Teaching, the Yale Center for Scientific Teaching, and the National Academy's Summer Institute on Undergraduate Education. In 2011, President Obama awarded her the Presidential Award for Excellence in Science and Engineering Mentoring in recognition of her pioneering work in education. Not too shabby. So Dr. Handelsman joins a growing list of Wisconsin expatriates who have come home. So previous to being at the White House, Dr. Handelsman was the Frederick Phineas Rose Professor in the Department of Molecular, Cellular, and Developmental Biology at Yale University. And prior to that, she served as a professor in the Department of Plant Pathology here at the University of Wisconsin-Madison. She was a faculty member there from 1985 to 2009 before she went to Yale. She served as the professor and chair of the Department of Bacteriology from 2007 to 2009, and in 2013 she served as the president of the American Society for Microbiology. Dr. Handelsman earned her BS from Cornell University and her PhD in molecular biology from the University of Wisconsin-Madison. We are truly fortunate to have her join us as a director of this wonderful institute and as a member of the faculty, and we are privileged to have her lead off this year's series on the Crossroads of Ideas. Dr. Handelsman.
Well, thank you, Brad, and thank you, Laura, for the invitation to speak tonight. It's really good to be home. That's, I think, the best thing I can say about the last 2 weeks since I started at Wisconsin Institute for Discovery, is it feels like home. I feel like I was in exile for 7 years, and that's too long. So I thank you all for being here and for all the warm welcomes that I've gotten in the Institute and on campus, and I look forward to connecting with many of you, old friends and new as well. But I wanted to talk today about a crisis that I think is emerging and becoming much more clear over time, and is finally beginning to get a little bit of presence in the public's mind. And that's the disappearance of our soil from the face of the earth. And I'm going to talk about the United States problem with this, but the problems abroad are far, far worse. And so this is emblematic of a much broader issue that's going on, but you'll see it's not good for us either. In about a week and a half, Steve Ventura from the Soil Science Department is giving a Nelson lecture, also in this room, and it's entitled The Life Beneath Our Feet, and he's going to talk about what soil is, why it's important, and then talk about some of the ways to protect the soil. So he's going to give you a very hopeful, upbeat view. I'll lay out the problems. So just in case you think it's a little odd to have two talks so close together, first of all, it was a coincidence. We were invited by completely different entities, and we didn't know we were both talking until about a week ago. But in case you wondered if you should go to two talks on the same topic, look at the history of our relationship with soil. It turns out that every major religion in the world has had some deity, and it's usually the highest deity, and often a female one, that represents soil, represents the earth. And this is a recognition from early societies, recent societies, that soil is the source of everything else that we need to thrive. For years, I couldn't find, these were all sorts of Eastern and Western religions, but I couldn't find an example in the Judeo-Christian tradition that indicated that that tradition also appreciates soil. And then I discovered this quote that says, "The Lord hath created medicines out of the earth, and he," it's supposed to be she, sorry, "that is wise shall not abhor them." And this is amazingly prophetic because it's absolutely true. Soil is the source of most of our antibiotics and many other drugs. And so also in the Bible, it was recognized as absolutely important. and worth revering. So go to Steve Ventura's talk. I expect it's going to be very informative, and 2 talks on soil is not too many in 2 weeks. So soil is familiar, right? Everyone's seen soil. Everybody knows what soil is. Most kids have actually eaten some soil. In Wisconsin, you see all sorts of views of soil. You see the open cropland between planting or between harvest and planting. You see garden soil, probably very close to many of you. You even touch it, which a lot of Americans, I've discovered, do not do on a regular basis. You see it at construction sites, and you see it piled up. There was a great pile of soil down by the Nat when they were doing construction a number of years ago. And because the project was started by Chancellor John Wiley, somebody went to the top and named it Mount Wiley. And it was a couple of stories high, so that was quite a trek getting up there. So we see soil in all these different forms, and it seems so familiar and seems so ordinary and mundane. But we don't really think about what's below the surface. And soil has an incredibly complex profile. If you dig deep, you begin to see not only is the standard look that we all probably have seen in our gardens or other places, but soils can have incredible coloring. This is an example of a soil from a very iron-rich area. And what you see in almost every soil are these beautiful striations. Now, I don't know if you think it's beautiful, but I think that the profiles of soils are one of the most gorgeous things on Earth. In fact, the Secretary of Agriculture had, up until a couple weeks ago, had these gigantic soil profiles, cores of soil that were about 12 feet high, lining the wall outside of his office. So some people agree with me that it is absolutely gorgeous and ornamental. And so you look at soils, and if you really begin to dig in, no pun intended, you begin to see this enormous variety, not only as you go down through the profile of the soil, but as you go across the world to different sites and different types of soils. So soil is enormously complex. There are thought to be hundreds of types of soil in Wisconsin alone. So it's not as if it's a uniform substance. Interestingly, Wisconsin has recognized how important soil is by nominating it, and it actually passed the legislature in 1983, a state soil, which is the Anago Silt Loam. And that is also a very good-looking profile. And it supports an enormous amount of agriculture, forestry, and other activities across the northern part of the state. And interestingly, it has become so popular that many people, I have discovered, know about the song, which is the ode to the Anago Silt Loam, which is shown there. And I think we're going to have a competition in the Wisconsin Institute for Discovery or the Discovery Building for the best rendition of the Anago Silt Loam soil. That song, that was actually written by a soil science professor, Francis Hole. Can you believe that? Name Hole for a soil professor. It's real though. And he was also a great poet and musician, and he created this great song. And it's been in place, and kids all over the state learn to sing the Anago Silt Loam song. So soil is not just something we grow our crops in, but it's really one of the wonders of our Earth. It's incredibly complex, and that's what I love about it, and that's why it belongs in the Wisconsin Institute for Discovery, because the theme of our institute is looking at very complex systems. And there's nothing that I know of as complex on Earth as soil. It's this heterogeneous mix of different sizes and different types of minerals. They're from geologic origin, and we call them sand, silt, and clay to indicate the size of the particles, and that sometimes also reflects their chemistry, but not always. It also has this living and rapidly changing composition of plant and plant material, animals, and microorganisms. And those are both alive, live roots, live worms, and live bacteria and other microbes, but also decaying or decomposing ones. And so it's this dynamic system that never stays the same for very long. And that's one of the beauties of its complexity, is that it's dynamic over time. So it has multi-dimensions to challenge a microbiologist or soil scientist. So the microorganisms are the dominant organisms in soil. So most soils contain well more than 1 billion cells of bacteria per gram. And there are also all sorts of other eukaryotic or higher organisms, fungi, protists, nematodes, small worms, and viruses. So it's an incredible complex of essentially every group of microorganisms that we know of, and many different types of them. So not only are they abundant, but their diversity is enormous. We don't know of a biological environment that has as many species of bacteria as soil. So it probably is the most complex and varied site on substance on Earth. The dynamic quality of soil is really what makes it so challenging to study and to replicate experiments in, and also to make generalizations about, because it's always changing over time. So there's the long geologic change over very long periods of time, billions of years, and then there's the very short-term change, and one that I think is really dramatic from a microbial standpoint is the phenomenon of plants that they take up water during the day, and then many of them will redistribute water by placing it into the soil at night. And so a typical oak tree will take up, a large mature tree will take up 80 to 100 gallons of water during the day, and then it will release as many as 20 gallons of water into the soil. So imagine being a microbe on a daily schedule. You're losing water at a steady rate all day, and then it comes flushing out of the tree that you live next to at a very high rate overnight. So that's the kind of dynamic quality that the soil has. And then, of course, there are micro changes going on at every scale that you can imagine. And I would imagine that being a microorganism is pretty challenging. So these alternating cycles at every scale, from geologic to momentary, make soil variable over time. But despite its variability, there are a few things we can say generally about all soils across the Earth, and that's their value. They essentially all have served some of the same purposes in every location on Earth. And the first, of course, is food security. And when we first started talking about soil on Earth at the White House, people were saying, oh, really, soil? I guess I never really thought of that as anything important. And then the movie The Martian came out. And all of a sudden, there was a great understanding of why soil is important. It was really fascinating how one movie could transform the view. And that was, by the way, the president's favorite movie in 2015. So we started talking about not only the future of soil on Earth, but NASA has a very strong interest in soil, because if we're ever going to colonize Mars, we need to figure out the soil challenge that, as you know, Matt Damon faced when he was trying to live on Mars. You can't really grow food without soil. It's also critical for climate mitigation. And this is one of its ignored features that is one of the ones that is beginning to come into the light a little bit more, and people are beginning to pay attention. You look at many of the climate change reports, and you can find perhaps a small paragraph out of a 500-page report about soil. So it's been ignored, but it's increasing, partly because I harassed a lot of people who write those reports and told them they're missing a big part. And the reason that they're missing a big part of the carbon is that soil, despite their ignoring it, contains an enormous amount of carbon, and we're talking 1,300 to 1,600, and there's a range there because the estimates are crude, of organic carbon just in the top meter of soil across the Earth. And that's twice the amount that we have in our atmosphere collectively, and it's 3 times the amount in all the plant tissue on Earth. So in most discussions of climate change and carbon dioxide and carbon levels, we focus on the atmosphere and the plants, and to some degree the oceans. And the soil is left out of the equation. And what happened during the time I was at the White House was some people were starting to say that our equations don't balance, and perhaps this is why. Perhaps if we paid more attention to soil, we would be accounting for more of the carbon in the biosphere. Soil is also critical for water quality and water availability. It's the biggest filter on Earth. So our water that we take from groundwater would be filled with all sorts of things from toxins and pollutants and gasoline and also biological substances if the soil weren't such a powerful filter. And by the time most water gets to the groundwater, in a good soil, a healthy soil that is filtering, it becomes potable. Water availability is also controlled by soil. The soil is one of the best storage tanks for water across the Earth. And shortages of water are often modulated and mitigated by the fact that the soil can hold so much water and then release it on a much more timely scale than the clouds do. And the biodiversity in soil is enormous. It's unmatched. So for those concerned about maintaining biodiversity on Earth, one of the places we should be preserving is soil. And as various kinds of soils have become extinct on Earth, it's kind of frightening to think of all of the extinctions of microorganisms that might have occurred in those areas that we'll never know about. And human health has been shaped by soil in many ways. Of course, food is the one we think of, but our drug supply is greatly shaped by soil. Because of the microbial diversity, there's also a chemical diversity, the chemicals that those microbes produce, and that has been exploited for actually hundreds of years in ways that we probably didn't know exactly what we were doing. My grandmother used to use soil as a poultice when kids got infections and in their skin. And it turns out one of the things she was probably doing was not introducing pathogens, which is what you might worry about, but she was introducing bacteria that were producing antibiotics. So most of the antibiotics we use in medicine today come from soil organisms, and then there are immunosuppressants and cancer drugs, heart drugs, a whole variety of other drugs that come from these varied bacteria that have a variability to produce different compounds. So soil is something we've depended upon for almost every aspect of life, including, by the way, the arts. There are a lot of very interesting books about soil and music and art that reflects the beauty of soil and its importance to human existence. The problem is that not all soils are healthy, and they don't stay healthy on their own. We have to do something to make them to protect them if we're going to be using them in the ways that we use soil today in agriculture and building and all the other things. And so if you look at soils in various parts of the world, you can see the effects of overgrazing and drought. You can see the effects of damaging the substratum that holds the soil in place and exposing these big tears in the earth that allow the soil to wash away. And so the soil begins to change chemically when it's exposed in either of these conditions, and it changes its properties in ways that take a long time to recover. And some of that recovery isn't expected to be on a human scale. We do damage in very simple ways, and this you can't actually fly over Wisconsin at this time of year since the snow melted and not see this site, and that's unprotected, uncovered soil. And for much of the Midwest, between harvest and planting in the fall and spring respectively, there are usually 8 months when the soil is unprotected. And many farmers will plow their soil in the fall so that it's disrupted, it's broken down structurally, and it's vulnerable to some of what you see here, this washout or erosion. So historically, we're not the first ones to notice that soil can be degraded and lost. Historically, there are arguments that say that many civilizations across the world have collapsed because their soils have collapsed. And I was skeptical of this argument, but if you look at the historical documents on this, there's actually a growing body that's quite interesting. So in ancient Rome, they plowed the hillsides aggressively. This was something that they've often been credited with because agriculture was so successful in Roman times. But they plowed these very steep slopes, and that disrupted the soil and enabled erosion. And it seems from some of the archaeological data that have emerged recently that one of the reasons the Roman society may have collapsed is that they weren't able to produce enough food anymore. And there's evidence that Rome itself was beginning to be inundated with soil by the time it began to decline in its power. Easter Island is one of the classic examples of an island that was severely deforested, which destabilized the soil. Much of it washed away into the ocean. And the population of people went in the 1600s from about 15,000 to a century later to 2,000 to 3,000. And so something happened there, and it's thought to be the consequence of the deforestation, which in itself was not threatening to human existence, but it threatened the soil, destroyed the soil, and the population has never recovered to that state on Easter Island, and they've never been able to recover the health of the original soils. And one that was proposed just last year that surprised a lot of people, there was a lot of discussion of this, you may have read it in the New York Times and other places, was the new theory from one of my colleagues at Yale that Hitler was actually driven by soil health more than anything else. And if you read Mein Kampf, which I can't do, but people who have read it in the original say that some of the ignored language till now has indicated that his prime concern was food for the German people. And he believed that the Jews were going to eat too much food and there'd be a shortage of food. And he knew that German soil was very vulnerable to running out of nutrients and being degraded. And that was the major reason that he invaded Ukraine. And the author of this book, Timothy Snyder, argues that we better think carefully about what parts of the world are being invaded now for their soil. The Ukraine has the richest, darkest, most beautiful soil on Earth, and that makes sense that it would be invaded for that. But I've never seen that discussed, except by this author, as one of the reasons that Russia has been so aggressive recently about the Ukraine. So there may be an interesting repeat of history. There are also other areas of the world, including some in Africa, that have been colonized by other countries specifically for their soil, but often that's not stated as the reason. So I think we need to be thinking soil when we look at world politics and think about what desirability there is in various countries or various areas that may be related to soil and not the more obvious things that we think they're being invaded for. Soil erosion and damage and degradation isn't new to the United States either. There's a long history of sites, things that look like this, where there are gullies that are washing away soil from productive cropland. And it's thought that we've reduced our topsoil across the United States by about half since 1850. That's pretty dramatic. That was topsoil that took many thousands of years to form, and now we're losing it in a matter of a few years. And of course, the big soil damage was that most people remember, but there are many other examples, is the Dust Bowl. And that was in the 1930s when, due to a whole series of different interactions, including mistreatment of their soils, the areas in the middle part of the country became damaged by wind removing the soil. And if the soil had been healthy, the wind couldn't remove the soil. So one of the lessons from all of these kinds of erosion, wind erosion and water erosion, is that healthy soil is a rich mixture of bacteria and other microbes that are producing compounds that hold the soil together. And when the soil is healthy, you get clods or clumps or aggregates. And those are much harder to degrade or erode because they're larger pieces. When the bacteria are disrupted by a variety of forces and aren't producing the glue that keeps soil aggregates together, or other things are happening that prevent the soil from forming aggregates, it breaks down, it loses its overall structure, and that's when it becomes vulnerable to erosion. And so people talked about erosion very commonly in the 30s, and actually Franklin Delano Roosevelt signed legislation that he pushed through Congress in 1936. It was actually passed in Congress in 1935, that led to the building of the Soil Conservation Service, which it has a new name now, but has been in existence ever since as the government's entity to protect soil. And there's this wonderful quote that he has from the day that he signed the legislation, and he said that the history of every nation is eventually written in the way it cares for its soil. The United States is now emerging from a youthful stage of heedless exploitation, that's been requoted many times, and is beginning to realize the supreme importance of treating the soil well. Well, I think that was a little bit extra hopeful. Sadly, we have not ceased our heedless exploitation of the soil. Roosevelt wrote to every governor in the United States telling them about this legislation and asking them to ratify it in their own states. And in that letter, he said to every governor, the nation that destroys its soils destroys itself. And that was a recognition of the historical power of soil, the importance of soil in maintaining societies and civilizations across the world. Those are prophetic words, and we probably should heed them. But when we look at where we are 82 years after the passing of that legislation, we find that the national average, so this is averaged across all land in the United States, is 2 to 5 tons per acre per year. So 2 to 5 tons of soil per acre per year are going away. And that's a large percentage of the soil, and I'll show you some graphs that predict how long it would take to erode all of it. So the rate of formation of soil is generously, and I use generous numbers here, somewhere between 1/10 of a ton and 1/2 a ton per year, per acre. Well, if you do the math, that is not sustainable. How fast it will go away, of course, depends on how much we mistreat it and, of course, what the rate of regeneration is. And some people are working on ways to make soil regenerate more quickly. And so there are ways that we could be compensating for the loss of soil, but we're simply not at these numbers. There are areas in the United States that lose 30 to 40 tons of soil per acre per year quite regularly. And China and India have many, many regions that are much higher than the United States average. So we're not the worst in the world, but we are absolutely destroying our soil. One of the very scary things is that in years of severe weather or very aggressive thunderstorms, the Midwest is pummeled by very high velocity raindrops that break up these aggregates that protect soil health. And the severe weather in Iowa, which has been very well studied in terms of these weather events, has caused losses up to 100 tons per acre per year. And those are not unusual. They found many areas that are losing at that rate. So one year in Iowa, in one storm, they lost 100 tons, somewhere between 50 and 100 tons of soil per acre in that area. And that was in one storm. So in one storm, one afternoon, soil that was created over hundreds of years was lost in one day. So one of the reason that this is scary is that precipitation trends in this country are changing due to climate changes. And so there are good weather observations going back well over 100 years that look at severe weather events or heavy precipitation. And you can see, and this is fairly typical of most areas of the world, that in this country, the frequency sort of bounced around the average heavy rains, number of heavy rains per year. But after about 1950, we started seeing a trend. And you can see here that there was no longer bouncing around the mean here, but there was a steady increase in the number of events per year. So now we don't have any years, we haven't in decades, that are at what was our mean, so our mean has completely changed and gone up. So this is really serious because these are the most serious damaging events for destroying soil and removing it from where it belongs. This has already started to erode so much in Iowa that in some areas the topsoil is already all gone. And this is an aerial photograph from a colleague at Iowa State, Rick Cruz. And each of the very light spots that you see here are areas where there's no more topsoil. So what should be a rich brown landscape with a heavy, covering of soil is actually now getting down to bare substratum and subsoil. And so crops won't be grown in those areas after a very short period of time. That's pretty scary. And Rick assures me that this is not an unusual sight, and if you fly over Iowa when the soil is open and you can see there's no snow on it, you can actually observe this quite easily. So it's not just a problem of the soil being taken away from the areas that need it, but the second part of it is, where does the soil go? And there are many, many answers to this. But some of it goes into the Mississippi, much of it, and ends up in the Gulf of Mexico. And so some of the nutrients from farms will just go into the Mississippi and down to the Gulf by themselves. But some of them go carried on soil particles and then get released along the way. And this is an example of the damage that's done. There are about 7,900 square miles of area of the Gulf that are hypoxic or oxygen deficient to the point that they're called dead zones and organisms can't grow. This has been devastating, of course, to the ecology of the region and also to the economy because it's disrupted the shellfish industry enormously. The EPA has collected these data, and this was as of 2014. They've been working on a steady campaign to try to clean up both the Mississippi and restore the hypoxic zone to normal functioning over the last few years. And if you look at the yearly data, it's actually getting worse. So this is not an easy problem to mitigate, even if you invest in it and try to protect it. So my office at the Office of Science and Technology Policy started thinking about, well, how long do we have left and how quickly do we have to act? And of course, that's a tough problem to address because we don't know. There's so many variables. We don't know how people are going to treat their soil in the future. We don't know what rain events will damage it. But we did some calculations, and this is looking at a standard Iowa soil based on the amount of soil that the Iowans say is in their topsoil. And if you look at the national average of soil loss, that's this curve or line, and you can see that at the national average, we would have topsoil, at least some, out to probably somewhere in the 22nd century. Which sounds pretty good, but it's still not sustainable if we're planning to be around for more than a couple of centuries. The other problem with that, even if it is at the slowest rate of erosion, is that as the soil erodes, crop yields decline. And there are areas of Ohio that have already seen 40% loss of crop productivity due to erosion, even though they're not down to bedrock or anything close. They still have soil, but they don't have as much, and it's really affecting productivity. So this is going to be a problem even if it goes at that slow rate. But large sections of at least Iowa, and this is true of many states that have any slope whatsoever in their land, are going much faster. And so if you look at, for example, the yellow line, that's at 25 tons per acre per year. And in Iowa, last year, there were 500,000 acres that were eroding at that rate. So that's a lot of Iowa that's going at that rate. And as you can see, we won't have any soil on that land by 2055 if it keeps eroding at that rate. And it gets worse, of course, when you look at higher erosion rates. There are areas, as I mentioned, that are being eroded at 100 tons per acre per year, and that's the most aggressive line here. And that means those areas, if they keep eroding at that rate, will have no topsoil by 2025. So this is not some dire prediction for way off in the future. This is starting to affect crop yields and has been affecting crop yields for years, and it is becoming quite dire given these numbers. So if we imagine that the numbers I just showed you are with current weather events, and then we imagine this line continuing to go up in terms of the number of powerful weather events per year, you can imagine that those are underestimates of how rapidly the soil will be disappearing. So, okay, there's good news here. So that was kind of depressing, I know. But the good news is that we actually know how to stop soil erosion, at least in cropland, which is where most of the erosion occurs. There's been fabulous research for years at places like UW and other agricultural schools to look into different methods of farming that will allow the soil to regenerate, become healthy, form those nice clods or aggregates, and be less vulnerable to erosion. And so some of the ones that have gotten probably the most press and have been shown to be tremendously effective are no-till farming. Plowing is probably the most destructive thing we do to soil because we're breaking those aggregates. If you farm without plowing, that reduces soil erosion dramatically. Cover crops, as far as I'm concerned, you should never be able to fly over Wisconsin and see bare soil at any time of year, but particularly not for 8 months over the winter. So using cover crops that last over the winter, anchor the soil, add organic matter or plant matter to the soil is really a very simple and biologically sound way of protecting the soil. Intercropping, I'll mention a little bit more about that, using a mixture of crops of different plants in the same area. There are some plants that are much more destructive to soil, like corn, and other plants that are restorative to soil, like many of our prairie grasses and legumes. And we can improve soil health by emphasizing the right species, and that doesn't mean stopping growing corn, and I'll show you some data about that. So if we have all these great methods, what's gone on? Well, there was an act in 1982, a Food and Soil Act, that made a very big difference. And you can see here the average rate of soil loss over time across the country. So this is a very, very gross average. But the USDA documented that the soil loss was pretty dramatic after the passing of this act that had some very strict and highly regulated and accountable requirements for farmers to adhere to in order to satisfy certain standards. And one of the big ones was when they put land into a crop reserve. They take it out of production, they can get a certain amount of money from the government. And in order to do that, when this law was first passed, they had to demonstrate that they were treating the soil properly and that there were a set of criteria that they had to fulfill. And this really had an effect. I mean, this was pretty tremendous, I think, in terms of progress in the first 10 years. But you notice that it starts leveling off here, and there hasn't been a whole lot of progress. And in fact, in the most recent reports from USDA, it looks like it might be ticking up a little bit. So this was not a sustained effect. And there were a number of things that gave rise to that. So in 1982 and 1985, there were food security and food and soil acts that reduced erosion a lot because they had accountability measures. And then in 1990, the Clean Air Act, surprisingly, had a tremendous effect on soil because of acid deposition, which was very damaging to soil, and that was reduced tremendously. And this recovery has been slow, but at least it's been in the right direction. But since then, Congress has passed repeated farm bills that remove the accountability from the original Food Security Act. And so now, in many cases, to demonstrate compliance with taking land out of production and show that they're treating it right, farmers simply have to say that they're doing it. They can self-certify. There's no mechanism of holding them accountable from the outside. And so the USDA that manages this is sort of hamstrung because they don't have the funding. The funding's been cut for accountability measures, and they don't have the jurisdiction to do so because of the Farm Bill. So recently, we had a Secretary of Agriculture, Vilsack, who is from Iowa and is very respectful of soil, and really passed, I think, some great policies on conservation and the land in conservation programs across the United States grew by 200 million acres, which is a dramatic increase. The problem is most of it wasn't for soil conservation. So farmers can do lots of different kinds of conservation. They can do wildlife conservation or other conservation. And it turns out a small minority of those 200 million acres were actually dedicated to practices that would restore the soil. So even when we make really good moves, like moving land into conservation programs, we don't always pay attention to the soil. But this is more of the good news. So this is an example of the kind of research that's going on that I think is transformative for agriculture today in terms of protecting the soil. So this is a program called STRIPS, which is the use of strips of alternate crops, other crops besides corn, to restore the soil within the very field that the corn is growing. And so this was thought of by actually one of the members of the team is a graduate of UW, and they decided, well, maybe you don't actually have to plant the whole area to the prairie plants or the legumes that have these rich, deep roots that have such a great effect on soil. Maybe you could just insert a little bit. And they did that, and by taking only 10% of the corn out of production and replacing it with prairie plants for those short strips, they found that they could reduce the runoff by 37%, and the erosion went down to about 1/10, and in one study, it was 95% reduced. So this is an enormous reduction, and it's simple. So when we brought this up in Washington, we talked about, well, what's the problem? Why aren't farmers doing this? It turns out that one of the challenges is our crop insurance programs. And crop insurance is based on the amount of land that was in production last year. So if a farmer takes 10% of the land out of corn production, then he or she will get 10% less crop insurance. This seems like a really simple thing to solve, right? Believe me, it wasn't. And we don't have it solved. So the question is, how do we encourage the use of these protective and soil regenerative practices that we know work? We just have to get them implemented. I mean, an example is about 1/3 of our acreage or less, most of the country, is in no-till farming. In Brazil, about 80% of their acreage is in no-till. Yeah, what's up with that? Why aren't we practicing the very practices that we discovered in this country? So my office, the Office of Science in OSTP, commissioned a report. We put together a committee of all of the agencies that have equities in soil, and we asked them to develop a strategic plan, and it was 15 agencies. So when I first started this, I thought, oh, okay, maybe there are about 5 agencies that would care about soil, and I couldn't even come up with 5, but I was being generous. The obvious one being USDA, and then you could imagine maybe DOE and NSF. Well, it turned out 15 agencies. The Department of Defense was one of the most active members of this group. It was tremendous, the energy and the excitement and the commitment that all these agencies had. And we thought if we could get 15 very diverse federal agencies to agree on something, it would be really strong policy. But I was skeptical we'd ever get them to agree. But in fact, they did. And they started toward developing a federal strategic plan, which is due in June of 2017. But we wanted to see something before we left the administration. And so we asked them to develop a framework for the plan that they will flesh out. And that was due in December 2016. And they released it, we released it on International Soils Day, December 5th. Bet you didn't know that, right? Celebrate it next year. And they recommended 5 major areas of change. And the first was they want social science to figure out why farmers don't engage in the practices that would protect their soil. So what do we have to do? What's the human behavior? This is a behavioral economics challenge, and a bunch of other fields will come into play. They noticed what we'd been working on for a while, which is that we don't have the right infrastructure for data about soil. And in this era of big data, where everyone across the world is collecting data about soil, and we could be learning so much from integrating that, we don't have a common means of collecting the data, storing the data, and making it interoperable among systems. They also suggested that all these agencies, all 15 of them, coordinate, amazing for the federal government, and support research in a coordinated fashion to look at the soil-climate interface, because that is clearly one of the big issues of the future, soil being the place that so much carbon is stored. And this, if they all got into it, we had 15 agencies doing it, would really put soil into the discussion of climate actions. And then to support research that helps us understand and manage land use, land under these changing uses, which are really quite dramatic these days. We're becoming more urban. We're using less land in agriculture in certain areas and more in others. There's a lot more urban agriculture. So what is this going to mean for soil? And so they felt that that needed to be studied. And then finally, to figure out what kinds of incentives would get people to manage their land in a sustainable way that protected the soil. So we asked for input from public groups several times. We had meetings at the White House. We had a call for information that was on in the Federal Register. We got incredible input there, a few hundred responses till the day that we actually closed the request. And then on the day that it was closed, we got 7,000 more responses. It was incredible, including a petition from actually thousands of scientists who all supported this framework idea and urged the government to act on it. So it was a pretty amazing process. And then on December 5th, on International Soil Day, we also announced several actions by the federal government and ones that we had elicited from the private sector that were quite varied. One was Department of Energy started to invest in research in soil at a larger scale. USDA, the Ag Research Service, did the same thing. They told us that they were going to create a new program as a result of what we asked them to think about that was $20 million per year in soil. The Smithsonian included soil in their 100-year biodiversity plan. Universities across the country have amazingly innovative programs. The University of Alabama organized 15 different institutions, universities and otherwise, that are working together to look at urban use of soil and what kinds of policies could be used to protect soil during this time of urbanization. Several universities are hiring new faculty, and some quite a few. One place said they were going to hire 50 faculty to study soil. Haven't seen it yet, but it sounds impressive. And then DOE's Lawrence Berkeley Lab dedicated new funding to the use of microcosms for modeling soil, and they're using synthetic biology to engineer soil and improve crop productivity. Cal State developed a new regional soil lab. And the one that I found the most surprising that called us out of the blue was a venture capital company that was investing $200 million in soil. And we asked them, why would this be profitable? And they are taking what they expect to be about 8 million acres of land that is degraded, restoring it to health, and using practices that will build the soil, organic matter and the structure of the soil, and then sell it. And so they're actually predicting that it will be highly profitable, and this will be perhaps a new way to get people interested in investing in soil, because they can make money on it. So we really need to be thinking about the past for planning our future, and we need to ensure soil for our food production, for protecting our planet from changing climate. We need the soil for drug discovery, and we need to protect our waterways, such as the Gulf of Mexico, from further pollution. And we've been told for a long time by others, FDR said this great thing about the nation destroying its soils destroys itself, but it goes back much further than that. And Da Vinci actually said, made the observation that we know more about the movement of the celestial bodies than about the soil underfoot. And that's still true today. We know more about astronomy than we do about soil. So part of the argument that our charter group of the agencies is making is we need a bigger investment in soil to figure out how to preserve it, protect it, and sustain it for a long future. I just want to thank some of the people who worked with me on this. Parker Leotode, Rich Poyat, and Kei Koizumi are all members of the OSTP team who did fabulous work on generating many of the commitments that I told you about, and helping the agencies write the report. Rich Cruz has been a fabulous help in providing data from Iowa in looking at what's happening in the soil, and Pat Pointer from Wisconsin Institute for Discovery helped me with a lot of graphics. With that, I'd like to thank you for your attention, and I'm happy to take questions.